Imagine, you're strapped into a 70-ton metal tube.
Okay.
You're rocketing down a strip of asphalt at 160 miles per hour.
That's like a standard Tuesday.
Yeah, exactly. The engines are screaming, the runway is rapidly running out, and you pull back on the controls. You're expecting the aircraft to, bite into the air and lift off.
But the air just isn't there.
Right. Well, I mean, it's there, but the molecules are so spread out from the blistering summer heat that the wings just kind of slice through it. They don't generate any lift. You thought you had 2,000 feet of runway left, but the physics of the sky aggressively disagree with you.
And that is the terrifying reality of aerodynamic physics. On the ground, a 90-degree day just means you turn on the air conditioning.
Yeah, you take off a sweater.
Exactly. We live in this world of context and flexibility, but the moment you try to leave the ground, that margin for error just completely evaporates. The physical reality of the atmosphere dictates whether you fly or, well, whether you fall.
Okay, so let's unpack this, because today we're taking you on a deep dive into two incredibly fascinating documents. And on the surface, they seem miles apart, but they are deeply intertwined by this shared obsession with absolute flawless precision.
They really are.
So our first source is a breakdown of the language of aviation. It's basically the highly specific abbreviations that pilots and air traffic controllers use to quite literally stay alive.
And the second document, well, this one is just wild.
It's mind-blowing.
It's a highly classified master system prompt from April 2026 for the Nizam Aviation Academy. We are essentially looking at the foundational rulebook used to command an artificial intelligence.
Right, it dictates exactly how this AI has to mass-produce aviation training content for the next generation of pilots.
It's a fascinating contrast between human survival and algorithmic training.
Completely. So the mission today is to figure out why the aviation world relies on such rigid standardization to survive.
Yeah.
And then how modern algorithms are exploiting human psychology to teach those exact high-stakes concepts.
It's quite the journey.
Oh, we are going to unpack how all of this works. And actually, I promise you, later in this deep dive, we are going to look at one specific crash report mechanism that totally changed how AI is secretly programming the brains of future pilots. So keep that in the back of your mind.
That part is particularly unsettling.
It really is. But let's start with the language of the sky. Our first source drops us right into a control room. You hear a voice say, ACC reports AAL deviation near controlled airspace.
Right, and if you don't instantly translate that, a disaster could already be unfolding.
Exactly.
The crucial takeaway from the source here is that these abbreviations aren't, text message shorthand. Nobody is trying to save characters like an old Twitter post.
Right, it's not like saying BRB or LOL.
No, not at all. This is a highly engineered data transfer system. Every single syllable is optimized to transmit maximum situational awareness in the minimum amount of time, especially over radio frequencies that might be staticky or really congested.
So take AAL, for example, above aerodrome level. It's a completely separate concept from the altitude you normally hear about on commercial flights.
Yes. Because if a pilot says they're at 1,000 feet, the immediate life or death question has to be 1,000 feet above what?
Right, above the ocean, above a mountain.
Exactly. The distinction dictates whether an aircraft clears a mountain or flies straight into it. Above mean sea level or AMSL tells you your height relative to the ocean.
Okay.
But if you're flying into, say, Denver International Airport, the ground itself is already 5,400 feet above sea level.
Oh, wow. Okay, I see where this is going.
Yeah, so if your instruments say you are at 6,000 feet AMSL, you might feel totally safe. But if you look at your AAL, you're above aerodrome level, you realize you're only 600 feet above the actual tarmac.
That's terrifying. So AAL basically grounds the data to the specific runway you're aiming for. It strips away all that global context and focuses entirely on your immediate deadly relationship with the concrete right below you.
Precisely. It's hyper-localized reality.
And then there's ADA, aerodrome density altitude.
Yes, the invisible killer. ADA is altitude corrected for temperature and barometric pressure.
Okay, so wait. Is ADA basically like the feels like temperature on a weather app, but for an airplane's wings?
That's a brilliant way to put it, yeah.
Like the physical airport might be sitting at 2,000 feet, but because it's a scorching hot day with a low pressure system sitting over the city, The airplane feels like it's trying to take off at 4,000 feet.
Exactly. And you can take that analogy a step further into the actual mechanics of the engine. A jet engine breathes air, it mixes it with fuel, and ignites it to create thrust.
Right.
Meanwhile, the wings need a really dense cluster of air molecules to flow over their curved surface to generate the pressure differential we call lift.
But hot air expands.
Exactly. The molecules spread out. So when the air is thin, the engine is starved of oxygen, meaning it produces less thrust. And the wings are starved of molecules, so they produce less lift.
Meaning the pilot pushes the throttle to the absolute maximum, but the plane is just sluggish.
Yes, the takeoff roll extends dramatically. If a pilot calculates their required runway length based solely on the physical altitude, and they just ignore the ADA,
They're going to run out of pavement.
the aircraft will chew right through the remaining asphalt before the wings can physically carry the weight of the fuselage up into the sky.
That level of operational awareness is just insane to me. And, it's not just about altitude either. The source brings up ADF, the automatic direction finder.
An absolute classic piece of aviation tech.
Right. It's this older navigation system that points the aircraft toward a ground-based radio beacon. But I'll admit, I'm a little kind of confused here. In an era where my smartphone can triangulate my exact position on a hiking trail using space satellites, why is a multi-million-dollar jet rely on ground radios?
Well, redundancy is the religion of aviation. GPS relies on a delicate constellation of satellites in orbit, and those signals can be jammed, they can be spoofed, or they could simply fail due to something like a solar flare.
Okay, so you need a backup that can't be messed with from space.
Exactly. The automatic direction finder is beautifully primitive. It operates on low and medium frequency radio waves, very similar to AM radio.
Right.
And because of the wavelength, these radio waves actually follow the curvature of the Earth. They don't require a direct line of sight like higher frequencies do.
Oh, that's clever.
Yeah, so a beacon on the ground broadcasts a continuous signal, and a physical loop antenna on the aircraft rotates until it finds the strongest signal. It essentially paints a crude but entirely unhackable arrow on the pilot's dashboard, pointing directly to safety.
So we have a really clear picture of how a single aircraft survives its immediate environment using AAL, ADA, and ADF. But the sky isn't empty. There are, roughly 10,000 commercial planes in the air at any given moment?
Something like that, yeah.
How does the global network prevent them from just blindly colliding at 500 miles per hour?
Well, that's where the architecture shifts from the cockpit to the ground infrastructure. The source introduces a simple foundational term, ACRE. It just stands for aircraft.
Right, short and sweet.
Yeah, it's the standard notation across global technical logs and flight plans. But the true maestro orchestrating all those ACCs is the ACC.
The Area Control Center. The source describes this as the invisible backbone of global air traffic. So when a plane leaves the local airspace around an airport, it gets handed off to an ACC.
Correct. These centers manage the cruise phase. They're massive facilities, often in these dark rooms filled with radar scopes, and they're managing thousands of square miles of sky.
Sounds intense.
It is. Their primary function is separation. They carve the atmosphere into these three-dimensional blocks, and they assign a specific altitude, speed, and heading to every single AC.
But wait, I've always wondered about this. Radar has limits, right? Like a radar dish on the coast of New York can't see a plane halfway to London. So how does an ACC manage planes over the middle of the Atlantic Ocean?
Oceanic control is a fascinating puzzle. Over land, radar paints a real-time picture. But over the deep ocean, ACCs historically had to rely on procedural separation.
Procedural, what does that mean?
Pilots would report their coordinates via high-frequency radio at designated waypoints. The controllers essentially used a giant mental chessboard, ensuring no two planes occupied the same block of time and space.
So they were just trusting the pilots to be exactly where they said they were.
Exactly. But today, we have satellite-based ADS-B technology. The plane broadcasts its GPS location up to a satellite and then down to the ACC, which effectively creates radar coverage everywhere.
That's incredible. And when that plane finally crosses the ocean and descends toward a dark, unfamiliar airport, it might rely on the ABN, the aerodrome beacon. The source highlights this as a visual navigation light.
Right, because after hours of trusting invisible digital data links, the ABN provides raw visual confirmation. It's a powerful, rotating beam of light, usually alternating white and green for civilian airports, just cutting through the night sky.
It's the airport physically signaling to the pilot, hey, I am here.
Exactly.
But the systems fail. Human error sneaks in. And that introduces the heaviest, most sobering abbreviation in our entire deep dive, the AAIB, the Air Accident Investigation Board.
Right. Or depending on the country, the NTSB, the National Transportation Safety Board in the U.S. When metal bends and the unthinkable happens, these are the organizations that step into the wreckage.
And their mandate is singular. Answer the question, what happened and why?
That's it.
I found the philosophy behind this so profound in our sources. The script emphasizes that the AAIB does not investigate to place blame. They don't exist to throw pilots in jail or, sue airlines. Their sole purpose is to find the flaw in the system so it can be fixed.
You have to consider the alternative. If an investigation board acted like a police force seeking criminal charges, every pilot, mechanic, and air traffic controller would immediately invoke their right to remain silent.
Oh, totally. They'd hire lawyers right away.
Exactly. The truth about a mechanical failure or a psychological mistake would just get buried under legal defense strategies. By stripping away the threat of punitive action, the AAIB creates a safety culture.
So a pilot can say, hey, I got confused by the altimeter reading, without fear of utter ruin.
Yes, it's an environment of honesty for the sake of survival.
It's the ultimate systemic feedback loop. The entire global network of ACCs, the strict adherence to AAL and ADA, all of it is built on the findings of past AAIB investigations. The rules of the sky are quite literally written in the blood of past mistakes.
Which presents an enormous logistical challenge. If the system demands this level of unyielding, globally unified standardization, how do you teach it?
Right.
You can't rely on human instructors who might, say, summarize a concept poorly or let their personal biases alter a procedure.
You need a standardized teacher. And that brings us to the second document we're unpacking today, the April 2026 Master System Prompt for the Nizam Aviation Academy. This is where the story pivots from the strict rules of the sky to the rigid rules of the algorithm.
The prompt is essentially a consolidated instruction manual for an artificial intelligence. It commands the AI to automatically generate educational video scripts, podcasts, and study materials. And the level of micromanagement is just staggering.
It completely removes ambiguity. Let's look at Rule 6 from the document Deep Research Before Production. The AI is ordered to research all terms, including standard pronunciations, before it writes a single word.
Right.
It explicitly commands that ICAO, that's the International Civil Aviation Organization, the UN agency that sets these global standards, must be pronounced phonetically as ICAO. Meanwhile, the FAA, the Federal Aviation Administration in the U.S., must be spelled out letter by letter, FAA.
The AI isn't allowed to guess. It forces the machine to speak the authentic operational dialect of an aviation professional. Because if a student hears a computer voice say the FA instead of the FAA, credibility is instantly destroyed.
Totally. The voice requirements in Rule 9 are even more aggressive, though. The prompt dictates, in all caps, that the AI must use a female voice. Always. And this applies across the board, whether the video is being generated in English, Turkish, Arabic, Hindi, Spanish, or German.
It's incredibly strict.
And the tone must be calm, professional, instructor-level authority. It even forces the AI to set the audio generation style parameter to absolute 0 to ensure there is zero emotional exaggeration.
And the document justifies this by stating that changing the voice between episodes destroys brand identity.
Okay, I have to push back on this because it feels incredibly contradictory. On one side of the prompt, we have Rule 9 forcing this singular, emotionless, standardized voice to protect the brand. But then we look at Rule 18, multilingual adaptation.
Yes, the adaptation rules.
The AI is strictly forbidden from doing direct, literal word-for-word translations. It has to adapt culturally. If the output is Arabic, it must include right-to-left visual notes. If it's German, the AI must cross-reference terminology with ESA, the European Union Aviation Safety Agency. If it's Hindi, it has to frame the context around India's regulatory bodies.
Right.
So they're hyper-localizing the cultural context visually and legally, but violently enforcing a single, monotonous female voice across the entire planet. How does that make sense?
It seems bizarre until you evaluate it through the lens of cockpit psychology. In an emergency, a human pilot is fighting a massive adrenaline spike. The brain's amygdala is just screaming.
Sure. Panic sets in.
Exactly. In modern aircraft, automated warning systems are designed specifically to cut through that panic. A calm, authoritative, often female voice stating, "Pull up," pull-up, is scientifically designed to lower the heart rate and force the pilot's brain back into logical processing.
Oh, wow.
By mandating this exact voice profile for hours of educational content, the Academy is essentially classical conditioning the student. The safety culture psychology simply overrides regional conversational norms.
They are basically programming the student's nervous system to associate that low emotion delivery with absolute truth and safety. The medium is the message.
Perfectly said. However, the AI isn't just programmed to teach facts. As we analyze the rest of this master prompt, it reveals an intense calculated effort to manipulate the digital algorithms that distribute the content.
As well as the psychology of the human trying to learn it, which is where we hit Rule 31 retention curve scripting. The prompt outlines precise timestamps where the AI must deploy psychological weapons to stop the viewer from clicking away.
It's gamifying education.
Exactly. It starts at minute 0 with a pattern interrupt. The AI is explicitly forbidden from starting a video by saying, "Hello, everyone, welcome back to the channel."
Because neurologically, a pattern interrupt jars the brain's default mode network. When you hear "welcome back to my channel," your brain predicts the next 10 seconds of filler and just tunes out.
Right?
By opening mid-action, perhaps with a terrifying description of a plane running out of runway due to density altitude, the brain is hit with novelty. It demands attention.
And the survival of the video depends on it. The prompt notes that YouTube suppresses videos that drop below 30% retention at the 2-minute mark. Which brings us to the retention checkpoint. At exactly 2 minutes in, the AI is ordered to drop a breadcrumb, a promise of something highly engaging coming later.
Do you realize what you did earlier in this very discussion?
I do. But at 2 minutes into this deep dive, I promised you, the listener, that we would look at a specific crash report mechanism that changed how AI trains pilots. I planted a retention breadcrumb. I used Rule 31 on you.
And it's highly effective. The brain hates an open loop. When a question is raised or a story is teased, human curiosity compels us to stay until the loop is closed.
Well, let's close that loop right now. The prompt mandates that the breadcrumb must be fulfilled between minute 7 and minute 8.5. It designates this as the real application peak moment. But the AI cannot invent a scenario. It must pull a real-world case study from public domain NTSB or AAIB accident reports.
The mechanism of a real tragedy is utilized to spike algorithmic engagement. The AI scours the databases of the Air Accident Investigation Board. It finds the exact moment a pilot misunderstood their AAL or misread an ABN beacon, resulting in a collision.
It's dark.
Very. It packages that trauma into the peak retention window where the viewer's psychological engagement is highest, prompting them to subscribe to the channel.
The optimization doesn't stop with the script either. Rules 29 and 30 govern thumbnails and SEO. The AI has a strict formula for titles, primary keyword plus secondary keyword plus a curiosity phrase. A human might title a video, Episode 1, Aviation Abbreviations.
But the AI is forced to write Air Law Abbreviations ATPL Exam Complete Guide EAP-01.
It even engineers micro-dopamine hits through YouTube Shorts. Rule 35 dictates 3 shorts per long-form video. The hook must land in the first 1 second, and the content is categorized by psychological impact.
Right, so Short 1 delivers the most surprising fact, Short 2 provides the most practical exam tip, and Short 3 presents a counterintuitive truth.
This forces us to step back and look at the reality of modern digital education. Think about what we've uncovered today. We started in the cockpit, analyzing the brilliant, life-saving precision of aviation language.
We explored how AAL keeps you from flying into a mountain, how AD respects the physics of hot air, and how the massive ACC network hands you off to a spinning ABN beacon.
And we established that the AAIB stands as the final, blame-free backstop, turning the worst human errors into the foundational rules of global safety.
But then we saw that exact same obsession with zero ambiguity turned inward on the educational process itself.
The Nizam Aviation Academy forces an AI to utilize a hyper-specific, emotionless voice, bans direct translation, and weaponizes the YouTube retention curve using timestamps and psychological open loops.
It is a profound contradiction. The AI is tasked with maintaining the rigorous, scientifically pristine standards of global aviation. Yet, to deliver that pristine data, it must wade into the gutter of the attention economy.
Or really does.
It uses the dopamine-driven algorithmic survival tactics of social media influencers just to keep a student focused enough to learn how to keep a plane in the sky.
Which brings us to a final, somewhat unsettling thought. In aviation, pilots are trained to handle hours of steady-state boredom. They stare at instruments in a quiet cockpit, maintaining intense focus on mundane data. But if the next generation of professionals is being educated by an AI that constantly blasts their nervous system with pattern interrupts, 1-second hooks, and artificial dopamine spikes every 2 minutes.
Are we destroying the very attention span required to fly the plane safely?
Right. If you can only learn through engineered shocks, how do you survive the quiet reality of the job?
The tool designed to perfect the training might be quietly eroding the psychology of the trainee.
Something to think about. So the next time you are learning a complex skill online, pull back the curtain. Look for the pattern interrupt. Wait for the 2-minute breadcrumb. Notice the formula in the title. Because once you see the rigid algorithmic machinery pulling the strings of your own attention, you will never watch an educational video the same way again. Stay curious, and we will catch you on the next deep dive.